Welcome to IT Emotion, where we make autonomous IT entertaining and informative. My name is Sun.
And I'm Josh. We're your hosts. Today we're going to be talking about fairness in AI with Chris Stocks, principal consultant at SolasAI. Everybody welcome Chris Stocks.
Welcome to the show, Chris.
Thank you so much. Thanks for having me.
Absolutely. Hey, tell us a little bit about yourself.
Sure. Let's see. I work at SolasAI, focused on algorithmic fairness, so measuring and mitigating or ideally eliminating bias in algorithms.
Interesting.
Yeah.
Awesome. Well, I'm excited to learn a lot more about that. To kick things off, we've got a little bit of an icebreaker game. You told us that you're interested in traveling, so we got some sounds of travel.
Ooh.
And we're gonna see if you can identify them. So, Son, you want to hit the first sound?
It's an ambulance, right? Is that in London?
Yeah,
UK ambulance?
it's a European ambulance.
European, okay.
Specifically German, but
Oh.
But yeah, that
sound the same.
probably sounds...
They might share ambulances.
I'll give you a point. You get a point. How about
they all sound the same. All right, second one.
Oh. Is that a vending machine?
That is
Yeah.
a vending machine. You got that correct, sir.
Thank you.
Now, the reason is vending machines are a piece of technology that often go counter to our desires, right? You just want a candy bar, and it just spits the dollar back at you. So we felt that was kind of fitting for this conversation.
That's right.
Sure.
And it is a technology of sorts.
Yeah.
The metro, like doors closing.
Actually,
Oh. Ooh, one more time.
There we go.
I felt good about that.
no, it was close, actually, but it was the airplane double chime.
Oh, of course.
That's right.
Yeah. Okay, that makes sense.
How about this one? We'll do it again.
I have no idea on that one.
This is probably the hardest one. You want to do it
Yeah,
one more
one more
time?
time, one more time.
chance.
No, I got nothing.
When you open the doors of a bus, that...
Oh, the hydraulics or whatever
Yeah,
it is.
the air brakes.
Correct.
Boy,
Correct.
That's a tough one.
Yep, that is. And the last one.
Sounds like a cruise ship or like a tugboat or something.
Yeah, exactly. A foghorn.
Foghorn.
Giant
Sure.
big
That's right.
horns on
Sure.
those boats.
Those are great.
Absolutely. Well, that's great to have broken some ice with you a little bit. People have probably known that you're well traveled, except for on buses. You walk everywhere. I'm assuming.
Never taken a bus.
Chris,
Yeah.
no.
I like to walk.
The wheels on the bus don't go round and round for
They
you.
stay stationary.
Okay. Understood. All right, so let's move on to some of the other conversations we wanted to have with you. What are some of the coolest things you've experienced in traveling? What are the most surprising things that you've kind of run into?
Ooh. Let's see. I like traveling to places that I don't know, like Slovenia, for example. I think might be my favorite country I've ever traveled to, and it was in sort of a larger trip, and like I would not have predicted that to be the case, but it was just awesome. Lake Bled, if you've seen that, it's just picturesque postcard, like perfect kind of blue water lake with like a castle in the middle or a church in the middle.
Oh, wow.
So just like you row a rowboat around, and I was definitely sort of surprised at how much I loved that country. That was like need to go back kind of territory. So that's always fun. Like some places like went to Tokyo, and it was like Tokyo's awesome, but I kind of expected Tokyo to be awesome.
Big city.
Yeah, but it's cool when kind of places exceed your expectations. I guess.
You get a surprise.
Yeah. That's always a fun part of travel.
Any suggestions on where to go? Best value for the dime, maybe?
I mean, Slovenia's up there. It's very cheap, but you still kind of get like everyone speaks English, and it's great food and all that stuff. But yeah, I don't know. I mean, you can go kind of budget still in like Spain and places that are like just closer to get to from here, especially. So
Definitely. I've heard
Yeah.
Portugal's a good place to
Not bad,
go,
Portugal.
and
Yeah,
even Turkey. I'd love to be on one of those hot air balloons.
that would be
You
cool.
know, I always see pictures of it. I'm like, that's not real. That's photoshopped. There's no way.
Not too far from here, you can just see air balloons outside sometimes, right? You know, there's like kind of picturesque areas people like to fly in the air balloon, so it can be fun to just see that.
Those kind of terrify me. I think because I don't understand them. I don't really get
either.
it. I don't know how they land where
Yeah.
they want to land.
It's like Mary Poppins with like an umbrella. Like I don't.
Right.
It's real.
Right.
It's Photoshop.
Could be.
I think they just have to be aware of the wind ahead of time, and you know,
Yeah.
if landing isn't hard. Not crashing isn't hard. You just let the air out slowly, but
Mm-hmm.
yeah, I don't think you have that much steering capability. But I could be wrong. Maybe they bring like one of those box fans and just blow themselves around.
Right.
Good point. It's a good point. Physics we'd have to check on, but yeah.
All right, so tell us a little bit about your background. You didn't start out looking at AI, right? You started kind of in a different field.
Sure. Yeah. Started in kind of economics and statistics. Wanted to be an economist kind of in undergrad. Took a job at the Consumer Financial Protection Bureau as a research assistant. Worked with a lot of just awesome economists, statisticians. Really liked working with them, but kind of found that, you know, that the pieces I really enjoyed the most were kind of the more data science, machine learning type. I mean, that was relatively new at the time, at least in the financial services area. So I really kind of the bug bit me there. And, you know, the fact that I didn't have to go to grad school for 6+ years to be an economist, that was sort of, you know, that moved the needle as well.
Yeah, that makes sense. So I guess there's sort of a kind of similarity between economics and machine learning, and that you're kind of dealing in an abstract thing, right? You're not dealing with concrete things in many cases, and you're dealing with large groups, right? In the case of economists, you're dealing with large groups of people and nations and things like that. In the case of machine learning, it's large groups of data that often represent those sort of same things, right? Whether it's the flow of money or it's people doing things or things like that.
Yeah. And I mean, I think the direction was really helpful because, like, economics as a field and statistics too, like, very, very careful, like building linear regression models that are simple, you know, mathematically, but constructed with just a tremendous amount of care. And, you know, you spend entire courses learning about all the issues with, you know, estimation and all the ways your estimates can be biased and things like that really aren't covered in machine learning, definitely not to the extent that they should. So I think having that kind of background is helpful. I think a little more traditional statistics could benefit.
Yeah, because there's in a lot of machine learning, or almost all of it, I think there's a certain kind of regression function where you make a guess and then you see how much it's off, right? And you use that to adjust it backwards, and the statistical accuracy of the way you do that really matters for having valid outputs, right?
Totally. I mean, I think there's an attitude that's, I think, fading away, but sort of, if it works, it works. Don't really need to understand why. A lot of ML is just sort of throwing a ton of data at a problem and building these hyper complex models using a tremendous amount of computing power and just kind of saying it predicts well on a holdout data set, so I'm good to go.
Right.
Well, it seems like you're quite an expert in fairness in AI, just in general with that. What do you mean by fairness, though? Can you share that definition to us and our listeners?
Sure. It's a tricky one, and it varies a lot. I mean, it's you know, you look at some of the academic work, and there's, you know, at least 30 definitions of fairness that you can kind of translate into mathematics in some form or fashion. A lot of them conflict with each other, trying to improve things using kind of certain ones would be illegal in many fields. So it's like the choice of fairness metric, which is motivated by the conceptual sort of definition of fairness, is really key. So sometimes, depending on the industry, depending on the space you're operating in, you have some guidance. In more like heavily regulated fields like credit and employment, there's kind of enough case law and regulatory guidance that we have a pretty good notion of kind of how to label certain things as more or less fair. A very simple version would be just looking at like demographic parity. So you're doing some sort of favorable thing, right? Maybe you're giving like granting credit or
Sure.
giving people a job offer. Just simply the proportion of the time you do that for women relative to the proportion of the time you do that for men, right? Very simple definition.
Sure.
That's adverse impact ratio, the 4/5 rule in employment discrimination, disparate impact, right? All these are kind of connected. But that's definitely not the only way you can conceptualize fairness. Maybe you're like systemically over or under predicting outcomes. Maybe you're, worried about kind of consideration of the base rate, right? Your model's going to flag many more women than men if it's
Sure.
predicting breast cancer, for example, right?
Yeah.
But that might be okay. So, there's you have to be sort of context specific. Sometimes you have like guidance or precedent or case law to draw on. But a lot of times in a lot of new fields, we have to just kind of think really carefully about, what makes the most sense in discussions with subject matter experts and things like that.
Certainly.
Yes. So would you say that traditional concepts of fairness sometimes vary from what we might mean when we're talking about AI or machine learning fairness?
Yeah, definitely. I mean, I think the measurement, a lot of it still applies, like how you can think about unfair outcomes.
Mm-hmm.
But in terms of like how they enter in and kind of what you do about it, there's a lot of differences. There's definitely a lot of concern, I think probably appropriately, about fairness in AI models.
Mm-hmm.
But we shouldn't lose sight of the fact that the alternative oftentimes, like a lot of AI models are improving on discretionary decisions made by individuals. And there's plenty of bias there too, right? Like,
Right.
I think even some of the more like credit scoring models, some are sort of better than others from a fairness perspective, but I would put any of them up against, a very kind of discriminatory loan officer just kind of in the back room making judgment calls.
Right.
So, that's not like a universal truth across domains. But, when you're thinking about algorithmic fairness, important to kind of think about, the alternatives and, human discretion has its issues too.
Right. And in essence, it's like a flawed system is often better than no system, right? Then it just comes down to someone's whim.
Yeah, I think that can be right. And then, on the
You iterate on it.
right, and ideally we're kind of societally progressing towards a more and more fair place, while also kind of expanding access and achieving business goals and things like that. And then sort of the more traditional statistical versus machine learning side, these machine learning models, the complexity is enormous, right? We have instead of using, maybe 12 data elements to make a prediction, make a decision,
Mm-hmm.
now we're using hundreds, using them in complex, non-linear ways with interactions, and all of that kind of adds up to a place where it's kind of challenging to understand why the algorithm is making the decisions it is.
Well,
And that makes it hard to understand how the fairness, unfairness is entering in.
And that's another great question. It's like, how does bias enter into the algorithm in general?
Yeah, I think there's a few different ways. Some related to the data, some related to the application of the algorithm. So on the data side, a lot of times, data is collected in some form or fashion in a way that involves humans. And bias can enter in, right? If you're using like utility payment data or something like that to boost people's credit scores that are paying their bills on time.
Right.
If the company collecting that data is disproportionately doing so in white neighborhoods instead of minority neighborhoods, that data is just going to be biased from just a completeness perspective, right?
Sure.
If you're using data on like academic achievement, but your data set only goes back 20 years, you got to be really careful with how you handle that missing data. Otherwise, you're disadvantaging mostly everyone over the age of 45 or whatever. So the kind of incompleteness and being careful about the data is important, and that that'll just feed its way through to algorithms and result in biased inputs. Label bias, also a huge one. If you're building a model on, say, like maybe some general like health risk model, there's a lot of research and activity about this. You might think about your label, right? The target, the thing you're predicting, oftentimes isn't available to you. So you have to use a proxy for it. So in the issue of like general kind of health risk, you might use how much money someone has spent on healthcare in the last year to define like how unhealthy they've been. And if you're like an insurance company, that makes a lot of sense.
Sure.
But health spend is affected by a lot of things aside from how unhealthy a person is.
Right.
Access, access to healthcare, right? Like healthcare deserts, and like there's wealth inequities that have been around for hundreds of years,
Especially in rural areas of
completely
different countries.
Yeah, and
Developing countries, right?
right, and all that stuff will feed its way into your label and results in you're predicting on something that you're treating as ground truth, but in reality isn't ground truth.
Mm-hmm.
So you can do all the kind of responsible modeling techniques you want, but if your input data is flawed, then you could be in a really risky position. And the application, I think, is a really interesting one too. Like recidivism models have gotten a lot of attention. So these are algorithms.
What is it called again?
Recidivism. So that's like the likelihood that someone who leaves jail or prison will eventually come back, like commit a crime that brings them back.
Kind of repeat offender laws.
Yeah. And it's a concept that's really important when you're thinking about like parole. Like ideally, the judicial system.
The likelihood of it's pretty high of reincarnation again.
Ideally, you wouldn't grant parole, or you would grant less often. There's models to predict that, which should be firing all kinds of red flags and from a bias perspective. But when judges have the opportunity to rely on these models in ways that are like discretionary, like they can choose to use the model output or not. Maybe they sort of choose to do so disproportionately in ways that unfavor minorities or something like that, right? You could have a really fair objective model, but if there's kind of a human involved, then that can lead to.
They can siphon the data of what's important and what's not, as long as they're not biased about it.
Yeah, and it's tricky because ideally we do want like human in the loop design, right? Like having humans involved in automated decision making is probably a good thing on balance, but you have to be really careful from a kind of bias or disparity perspective.
Yeah, and you can arrange systems to kind of produce a certain outcome, but that often seems to happen unintentionally. And so I kind of...
Totally. Well, most of it is unintentional, right? Like disparate impact is kind of the theory we're commonly operating under, where like a facially neutral practice results in biased outcomes. And, the legal theory there is like, if that's the case, the person building the model has to be able to justify why it's useful to their business. So yes, I'm granting credit less to group X. I can show you that they default more, and that's why I'm doing that. Mm-hmm. And then they're sort of insulated. But then the other side can come back and say, well, sure, they might be more likely to default, but you could have used this model instead that is just as profitable, it performs just as well, but it would be much less disparate in its net effects to this group, right?
Right.
So that's what we like, not to turn this into a product thing, but like at SolasAI, we spend a ton of time on that innovation side of like generating alternative versions of models that are, just as predictive and just as useful to businesses, but have less disparity or less discriminatory.
Yeah, so you don't have to throw the baby out with the bathwater. It's kind of the idea.
Right. You can keep your, just kind of tweaks, iterations to your model that can result in more fair outcomes while kind of maintaining your level of predictive quality, which it helps. It's not a cure-all, right? If you've got this biased input data or, systemic biases that go back hundreds of years, like, we're not going to solve the entirety of, racial injustice.
And those things continue to evolve too, right?
Completely.
So,
it result in these nasty feedback loops where, these models affect like so many decisions in our lives, right? Like, and really important pieces. Like these are not toys, right? These affect, access to healthcare, credit, housing, employment, the recidivism stuff we already talked about. So, these are kind of really high stakes scenarios.
Mm-hmm.
So very important that they be kind of like predictive and like well built, but also that they be, fair.
So it sounds like maybe you've talked about maybe three things that are fairness issues. One is the one you were just talking about, which is sort of self-fulfilling prophecies, right? You look for people who are doing that, and then you say, well, they're going to do that, so they do that no matter what.
Do it again.
Mm-hmm.
Yeah, right. Like you kind of force it through the decisions you make. Sort of bad system design, and then what I would call colorblind person, classifying colors, right? Someone who's red, green, colorblind or something like that, making them the one in charge of deciding what picture represents what color.
Mm-hmm.
They're going to have a bias there, because they don't see it. And so that's going to kind of feed into and corrupt the data, right? The garbage in, garbage out idea.
Yeah.
Are there other areas where people should be looking to see if they're being fair, unfair in their use of ML?
Yeah, I mean, I think just a lot of machine learning models are not tested for fairness at all, right? So there's some, I think societally, there's plenty of sort of lower hanging fruit.
Right.
And just like, I mean, there's a ton of tools out there for like assessing disparities in outcomes that are, I mean, ours is free, public available, like it's on our GitHub. Anyone can go just measure outcomes for bias. And that's really step one. And I think, you know, that's a huge gap. But yeah, I mean, I think in general, it's, these are sort of underdiagnosed. And then, you know, we don't even get to sort of the solutions stage. And the solution stage is a lot harder, like what you actually do with algorithms once you find that they are biased.
Right.
But even kind of getting there is something that I think, you know, we'll have to grapple with. And that's probably going to involve, you know, more regulation and ideally more folks kind of stepping up and doing things out of the, you know, because they want to, you know.
Right,
I think
right.
Yes.
Different industries are in their own journeys with this,
Totally.
right? So, I mean, like, tell us a little bit about the different maturities of the different industries. What industries are at what level right now?
Yeah, you mentioned the credit industry, for example.
Yeah.
Yeah. I mean, credit's a good example. Like we've had the Equal Credit Opportunity Act since the 60s. So it's been kind of a legal requirement to really be laser focused on fairness for a very long time.
Yeah.
And there's a very large like regulatory ecosystem at the state, federal level, private plaintiffs even. A lot of folks kind of very critically examining the decisions and the algorithms that are built and you know, effective challenge breeds really better practices, I think. So, you know, I think that's an example of one that is much more mature. But it's been really interesting. You know, we've worked a lot kind of interdisciplinarily. A lot of industries are kind of starting to catch on that this is a really important thing. There's, you know, new laws proposed around like insurance in Colorado, for example. So the insurance space is kind of starting to catch on like, oh boy, this is a big deal.
Sure.
Insurance, you know, algorithms are a huge part of the decision making. So,
So
but yeah,
they're going to continue to definitely have those journeys. Are there other industries that you think are starting to look into it that are just haven't, you know,
I think
dove in?
I think marketing will kind of get there too. I mean, there's a ton of like data science applied in the marketing context,
Consumer behavior.
just because there's a ton of money there.
Right.
But unless the marketing touches some fields that are kind of already, you know, more mature and robust from a fairness perspective, I don't think there's that much kind of testing going on there. So I would expect that'll be coming. I mean, there's
It's a
been
scary thought.
Yeah, I mean, there's the DOJ settled something with Facebook pretty recently about them showing ads for, I think it was housing. Yeah, but like allowing them to sort of filter by demographics, which is sort of a touchy issue.
Yeah, it's
Pretty fraught with potential for bias.
Yeah,
Right.
yeah. But you know, I mean, you can kind of extend that pretty easily, at least mentally, to like other products that aren't, you know, kind of the core of housing, credit, employment, healthcare.
Sure.
Yeah, I think that's sort of an interesting situation, right? It's the confluence of sort of different disciplines, right? Because the sort of traditional marketers are very focused on, you know, how do you make an appealing message, whereas, you know, your traditional, say, economists are very focused on how do I model things mathematically. And so as those come together, it's going to require those groups to speak kind of a different language.
Yeah.
So one of the kind of questions we've been thinking about here is the different professional bodies, right? Think like the American Medical Association, the bar associations in the various states. They have different ethical codes. And what it means to be an ethical doctor is very different than what it means to be an ethical lawyer. The rules for ethics, what's ethical to do, are different. Do you feel like that's going to be sort of how it goes with AI and ML, and that, you know, these ethical codes that different bodies have start to be reflected?
Yeah.
Or more ethical codes can be developed for different professions?
Yeah, that's really interesting. I mean, I think ideally, yes. I you know, like regulation drives a lot of this, but ideally it's not all of it. I mean,
Right.
and I don't think it is. I mean, there's plenty of industry players that are like affirmatively trying to do better. There's a recognition that these problems are real and that they you know, solving them is not only has business advantages, but has real kind of human advantages. And I think as that happens, like I have seen them, take inspiration from their kind of existing fields. Like I think the folks that are the best at this have interdisciplinary teams that are really effective. So in the medical context, like they'll, grab people that actually have expertise in the, disease states that they're working with to work alongside the machine learning folks who are also working alongside, the attorneys that are more familiar with kind of the larger space. So I would hope that kind of if folks kind of construct these interdisciplinary teams of folks who can, communicate with each other effectively, they can kind of draw on the like ethical standards of their fields in ways that are productive. So yeah, it's an interesting idea. I mean, we'll find out as it develops, I guess. Too.
It definitely sounds like there's a lot of interdisciplinary things that are necessary, though, right? Where, I mean, medical field, technologists, statisticians kind of coming together. Same thing we were just talking about with marketing. And so maybe that's how some of these new ethical norms need to be developed.
Yeah, I would think so. And I mean, to me, that's the best part. Like that's my favorite part. I don't know. I like getting to kind of dabble in, spaces across industries and get to sort of, like, I think I'm a better data science practitioner because I understand the law to some extent, right? I'm very careful to not give legal advice or imply that I can do so. But if you understand, like the law well enough to understand legal requirements, like you can code that in, and vice versa, right? The attorneys that really understand the statistics, they're able to engage a lot more, ask the right critical questions. And that applies on kind of the subject matter expert front as well. Like the ones that at least have a like conversational understanding of data science and the law are like much, much better equipped to kind of build these sort of holistic products that, they work when times get tough, right? It's not that hard to build a credit model when the market is just really hot and everything's going well. You kind of find out whether your stuff is good when,
and there's the downturn.
Yeah, when things change.
So there's been like a real expansion of AI tools over the last few years, and that can do synthesis to like Stable Diffusion and ChatGPT. How does fairness fit into those sorts of AI tools?
Yeah, it's a good question. I mean, those are, I gotta say, I was playing around with ChatGPT and stuff like everyone else, but
It's always fun.
Yeah, I was having a great time, and I was also like, oh, good, job security. This is
Especially from the legal perspective too, right?
Yeah, and it's not their fault. I mean, when you train a model on the entire internet, you're gonna get a lot of views kind of embedded and decisions encoded that are that reflect the training data. It's not
right.
And again, you can there are techniques that exist to mitigate that and try to sort of at least understand drivers of some of these decisions, which kind of can illuminate whether there's channels for bias, things like that. But yeah, I mean, models like that, it's I think pretty apparent how they could be just reflecting bias that already exists and creating these kinds of feedback loops that can get pretty sinister, but they're super cool. And I mean, not to say that the pros don't outweigh the cons, right? Like I've never been one that there are certainly folks in, my line of work who are just like, machine learning's useless. We don't need it. Like it's not worth it. I don't think that's true. I mean, the benefits are real. The models are, I mean, the more powerful models are better. They can predict better.
Sure.
When responsibly built, they can, even do so out of sample and when times get tough. But yeah, with stuff like that,
use cases aren't even fully understood at this point either. So it's going
to only get more true. I mean, as data too becomes more and more accessible, and we have just more and more options for data to use, you're going to have to be using methods that can accommodate that sort of thing in effective ways. But yeah, stuff like ChatGPT, I mean, that's on another level, and I don't think nearly enough. Like we're not ready as sort of a fairness community to handle things like that. I don't think.
It's kind of scary.
I'd love to try, but
things are moving so fast.
Yeah, and that's how it goes. I mean, there's sort of development. People get a little far out over their skis, and then that's sort of we kind of come behind and like, all right, let's do this in a responsible way.
The right way.
Yeah, that balances the benefits and harms appropriately.
Totally.
Yeah, well, it's an ever evolving field, right? And even taking all the information from the internet, if there were an internet in 1950 or 1880, and that was it, the system wouldn't be very useful today, right? Society's changed, technology's changed, understanding has changed, and so all the models need to update with new information, new algorithms, new ideas. The ethics need to update, the laws need to update. We all need to figure out how to deal with it, right? The radio, when it was invented, was overwhelming to people. Right? There's just way too much information in your house, and then we learned how to adapt to that. And now it's that's almost a quaint idea, right? That anyone would be overwhelmed by the radio.
Yeah.
And so I think maybe it's the same thing.
No, totally. I mean, I think like staying agile and like not pretending that technology is going to stay the same, but building the tools that'll allow us to kind of adapt when it changes. I mean, I think that's huge.
Absolutely. And Chris, thank you again for joining us today. I hope our listeners got tons of value in what fairness means, especially as it relates to, AI and moving forward in the future and the algorithm biases that we experience, whether we know it or not. And can you share with the listeners a little bit about where they can learn a little bit more about your work as well as you?
Sure. Yeah. Our website, solas.ai, it's really good. It's got like a lot of fun kind of resources. You can get like a bias checklist to, sort of evaluate your own algorithms, kind of make sure you're, doing your due diligence and things like that. So it'd be a good way to find us. I'm on LinkedIn as well, but
awesome.
But yeah, thanks so much. Really appreciate having me.
Well, Chris Stocks,
Thanks for coming in. It was a pleasure.
It was a pleasure, everybody. Once again, Chris Stocks. Thanks for listening, everyone. If you've enjoyed this week's episode, we'd really appreciate you hitting the subscribe button on your favorite podcast app. You can find us on YouTube, Apple, Spotify, iHeartRadio, Stitcher, and many other podcast platforms. We're adding new podcasts on a regular cadence, and you can also access all of our podcasts at ScienceLogic.com/podcasts.